game theory, and that leads to the previous slides, which is how to use it in CAM. So the second example, it could be interesting for those who decide to use to do online marketing, digital marketing, because one of the problems there is something called auction. So, for example, when you go to Google and you search for something, like a keyword, like let's say a keyword, I don't know, artificial intelligence, right? So there are certain slots on the search page. I think the first thing on the right hand side, the 3 more slots, those are advertised, sponsored. Right? So Google sells those slots to companies, and companies can pay money to put their name on it, but it's not guaranteed, so they have to bid, because there are more companies than slots available, so they have to bid for each slot. And that is something called auction. Right? They usually use something called second price auction, meaning that if I'm Google, you give bids to it, all of you are advertisers, you give bids to it, you say, I want to pay 5 cents. Other guy says, I want to pay 10 cents, and so forth. So I will take the first 2 winning, so the highest 2 bids. I'm going to give the slot to the highest bid, but I'm going to charge him with the second highest bid. Okay, do you understand? Do you get it? Okay, so that's why it's called second price. So in this case, you can formulate the problem as the following. So you are a bidder R, you are one of the bidders, one of the advertisers. This is the value for you to get that slot, because you think it's very important. If you place your advert there, the guy might click on it. So you can use some models, the nice models to learn what value could be. And then you need to place a bid. You say, oh, how much I'm willing to pay to win. Okay? And then the whole problem, if you look at this, then it becomes an online sequential decision making, because every round you have to decide how much I want to pay, how much I can get if I can win, and how much I'm willing to pay. Right? So you have to decide on the bid, and each of the bid value is in R. So classical auction theory, it doesn't work here very well, because first of all, it was designed to solve very small problems. So you have 3, 4 bidders, 5 bidders, 6 bidders, something like this. So it wants to understand the dynamic of the game and analyze it and do all kind of like fancy mathematical analysis. But when you have like hundreds of thousands of bidders out there, the solution of classical auction theory is not going to scale up. You cannot use them to optimize your bids. Okay? And another challenge is you don't even know who's out there. So lots of uncertainty. But then the idea is that why not using bandit theory? So you can use stochastic bandits, which we have done back in 2014. But you can also use adversarial bandits, because you don't care about other people's behavior. You don't care about how many out there. You assume everything is adversarial. Okay? So no stochastic behavior. And how to do so? So each arm, I already mentioned, each arm is a bid, value of the bid. And this is something now, the extra information, is that when you place a bid, you not only see whether you win or lose with that bid, but you can only see the result for the other bids as well. For example, if you place a bid of 100, okay? Let's say 100 cents. No, that's $1. Let's say 50 cents. Okay, 50 cents. And you didn't win. What does it mean? It means that someone has placed a higher bid, and so you're not the winner. But if you were not the winner, then anything you put between 15 and 0 would give you the same value as well, right? Because you wouldn't win either. Vice versa, if you put something like 70, you won. It means that you were the strongest one, right? You were the highest one. But it also means that anything higher than 70 would have won as well. So you have this kind of like semi-bandit feedback now, or observation feedback now. So you You place a bit, you see the value of the bit, whether you go or not, but you also see the value of all the bits. Not all, but some of all of them. And this is a very nice property, and you can exploit it. You can plug it into a Bandit model. And in this case, epsilon 3 again. And you update, instead of just updating the value of the bit, you update the value of all of the bits you have seen as well. Very tiny, but very straightforward trick. But it works very well in practice. And I think nowadays, a lot of people use this as well. Not just the classical bidding theory, but also Bandit-based bidding techniques to do the bidding out there. So you might answer. So I asked a question at the end of last session. Why we always try to compare against best tricks in hindsight? And actually, in real life, especially in this bidding strategy, in this online auction problem, it seems like it's quite useful because many people out there, they have very simplistic strategies. Like say, if the bid is is a slot, this keyword is this, then I bid 220. If the bid is that, so that the keyword is that, I bid